we've got our equations right here, except I've got a not a picture thing. Let's see. I could write in circles, but it would be a little bit difficult. Okay, so we've got, let's get rid of.
Oh, no.
Okay, we're just going to go back, 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 and then we're going to go down. Okay, so we've got our equation. It's right here. That's what I was trying to do. Okay, delta H is negative. That means that heat is going to go on the product side. So delta H negative, heat on the product side. It's being given off. If it was positive, it would go on the reactant side. Assume that has an equilibrium mixture of these substances. Predict the effect of each of the following changes. So we're just doing Le Chatelet. This is just doing Le Chatelet. So if I'm going to write this down here again, just without anything, well, I'm going to put the gases. O2 gas, 2SO3 gas. So this is what I was showing you the other day. So if I decrease the volume, what does that affect? Pressure. So if I have different numbers of gases on either side, then it will go to which side? Side that has the most or side that has the least? If I decrease the volume. The least. So over here on the left, I've got 2 gases here plus 1 gas, giving me a total of 3 gases on this side. On this side, I have 2 gases. So on the first one, if I decrease the volume, it's going to shift towards the side that has the least number of gases, right? If I add oxygen to the equilibrium mixture, I'm going to use green on this one. So I'm adding this. Remember I told you to use arrows going down all the time? Okay. Whatever I put in, wherever I put in something, it's going to go shift away from that. So it's going to shift that way. Okay, so I put in, it's going to shift to the other side to try and get equal again. Now, they did say that I had plus heat. Remember the heat was negative, so the heat's going to go on the product side. So on this one, I'm going to use black for C. If I raise the temperature, in other words, I'm putting in heat. Arrow down again. If I put in heat, I'm putting something in on that side. It's going to shift away from that side. The arrow keeps going in the same direction. It's going to go backwards. Okay, that's all they're asking in this one. Okay.
So can we do one like?
Yeah, we can do another one. What one would you like to do?
One that's like the
easy, but like the ones like with ice, like what's on the case.
Okay, so 1983 maybe, or
1983. Isn't that Taylor Swift's album?
I don't know. Or 88.
80.
Or 92.
88.
Or 95 is really close to it. Want to do 95? Okay, so I'll bring up 95.
That's the year I was born.
Wow, making me feel old, old, old.
I was born in 98.
Okay, so we're going to bring up our blank paper again.
I'm born in 2000. I was. Oh, you guys are 2000ers.
Okay, so here we go. Going again, reading what we've got. Let's start with what we have. So we have this lovely equation.
Yes, we do.
CO2 plus H2 gives us H2O plus CO, which is carbon monoxide. When H2 is mixed with CO2 at 2000 degrees Kelvin, equilibrium is achieved according to the equation above. In one experiment, the following equilibrium concentrations were measured. Equilibrium concentrations, so that's important. It's not the beginning or initial, it's the equilibrium concentrations. What is the mole fraction of CO? So all we have to do here to get mole fraction is find out how much total we have. So we have 0.2 plus 0.3 plus 2 times 0.55, right? Right. No, because there's water and carbon dioxide that both are that mass, or that molarity. We okay? And I'm going to assume 1 liter. So I add this up, what do we get total? Okay, 1.6. That's the total. Okay, and it's asking me to find the mole fraction of CO. So I take CO, which is 0.55, 0.55, right? CO divided by 1.6, and that's my mole fraction of CO. Done. What do we get? Should be close to 0.375? 2.6. 3.4? 3.4. Okay, and that's equal to the mole fraction
34%.
of CO. We don't do percent, we just go 0.34. That's a mole fraction. Okay. Using the equilibrium concentrations given above, calculate Kc. So I need to write Kc for this equation. Kc is equal to products over reactants. So concentration of H2O times concentration of CO divided by the reactants concentration of CO2 times the concentration of H2. Everybody okay with that? There's no coefficients, so I don't have to put anything to a power. Now I just go through and plug everything in. So H2O is 0.55, 0.55. Always, when you're doing your math on the AP exam, make sure you put a 0 point, because if you put a 0 before it, then we know there's supposed to be a point there even if we can't see it. But if you just do 0.55 and we can't see the point, that's a problem. Okay? Yeah, you might get marked wrong. Okay, yeah, and the world ends and life is not good. Okay, CO divided by CO2, 0.30, and I almost forgot the 0 there, and 0.20. I almost put 0.02. Okay, remember that when you're doing this, you want to make sure times to the top, divide, do an overall parentheses, times it, close the parentheses. You don't have to have those parentheses inside. Okay, so what do we get for Kc here? You should be writing this down because you got to turn this worksheet in with all the things done.
Well, I do better if I pay attention.
Okay, well this is going to be up. I'm recording it, so it will be up on the blog, so you can look at it again. 5.04. Okay, so what does that tell me? Is the reaction going forward or backwards?
Forward.
I have more products than reactants, so it's going forward for the most part. Now there is some going backwards, but for the most part it's going forward. It's not going forward all the way because it would need to be a really large K, but it's bigger than 1, so most of it's going forward, a little bit going back. Okay, next one. C.
KP in terms of KC.
Okay, so right, so we've got to do a conversion. Grab out your equation sheet from the AP exam that I've given you, and look on, is there an equation that goes from Kc to Kp, because it's not equal to each other? Probably. So let's figure it out. Anybody got it? We're looking for an equation that goes from Kc to Kp, or Kp to Kc. It'll be underneath your equilibrium area. Got it? Okay, so here's the equation. We couldn't find it on the sheet that we had, so I'm assuming that we'll have to remember it. The R is the gas constant R. T is the temperature that it's happening at. And remember, in gas laws, we have to have it in Kelvin, so they were nice and gave it to us in Kelvin. And delta N is the change in moles from one side to another for gases.
Which is 0.05.
So if we look back up here, all these are ones right here in this equation, right?
So they're all equal.
Okay, so we have 2 moles of gases on the products, and we have 2 moles of gases on the reactants. Everybody okay with that? 1 minus the other is 0, so this goes out to 1. Anything to the 0 power is 1, right? So Kc equals Kp, so all we have to do is say it's equal to 5.04. So the only time that it will change is if the number of moles of gases, and it has to be gases you're looking at, is different. If it's different, then you're going to have to times it by the gas constant times the temperature. Are we okay?
Where's the gas constant again?
0.0821 atmospheres times liters divided by mole Kelvin. But that is given on your sheet. You just need to remember which one it is. Remember, we've got a lot of R's.
8 R's.
Okay? Yeah. Wish they'd pick a different letter of the alphabet. Okay, when the system is cooled from 2000 K to a lower temperature, 30% of the CO is converted back to CO2. Calculate the value of Kc at the lower temperature. So how do I do this? You guys help me walk through this. And I'm going to say this, I'm going to circle this so I remember it. This is my CO. So I can get some more. Do we have to do ice? The temperature changes because that's not going to be consistent. So ice would probably be a good thing. Let's look and see what we've got. I got to bring this reaction down. Sorry, CO, I'm going to write it right here. CO2 plus H2 goes to H2O plus CO. Okay, and we do ice.
Okay, so initially we have
Okay, and initially we have 0.55 and 0.55, and which one was the 0.3? 0.2 is H2, so that 0.3 is CO2, right? Okay, so they said on D that CO changed by 30%. Was it decreased or increased? Because I can't see it. Decreased?
This is 30% of the CO is converted back to.
So decreased.
So we can put a minus on CO.
Okay, so do we want to do that right now? Or do we want to look and see, first of all, what that is? It is going to be minus, right? Because this is going to convert back, and these are going to get something out of back. So you can do that. We just don't know what yet. So we had 0.55. What am I going to do to that to figure out the 30% decreased? How do we find? Multiply it by 0.3, which is basically 30 divided by 100, right? Okay, so I'm going to erase that. What do we get? Now this is what you need to be writing down. You can't just assume and do it in your calculator and assume as readers we know what you're doing. 0.165. So now at this point I know I'm going to take 0.165 away from that, 0.165 away from that, and I'm going to add 0.165 to this and 0.165 to this. Is everybody okay with that? Okay, somebody take a column, each column.
Well, the first one's
0.465. Okay, and the third one?
0.395.
I'm taking your word for it. Okay, 0 point, the last one? The same, right? Okay, then we just plug it in to our K. So the Kc here would be products, H2O times CO, and do write this out because a lot of times we give credit just for this part.
And then you add the units in the part.
You don't add the units. You just plug them in, yep. So we're going to have 0.385 squared over
456.0.365 all over 2A.
No, not all over 2A. Okay, so now what we need to also remember again is when we hit the divide sign, we put this in parentheses. We don't have to use the red parentheses. We times this, and we close the parentheses. Okay, what are we going to get for an answer? Okay, what happened at this new temperature?
It
Is it going forward towards the products, or is it going backwards towards the reactants? We're having more reactants than we do products. So this is not favorable for the forward reaction, right? It's favorable for the reverse reaction at this temperature. So going back up to the question, it said to find the new Kc at that temperature, new temperature. Yep. Okay, so you guys are going to have to help me. We're looking at E now. In a different experiment, 0.5 moles is mixed with 0.5 moles in a 3-liter reaction vessel at 2000 K. Calculate the equilibrium constant of carbon monoxide. Okay, in moles per liter. So really quickly, what does that tell me? Because it's the same temperature, I can use that K. I can use that K. It's at the same temperature. It's the same temperature. Now, they've given me the beginning of ice. They haven't given me the equilibrium. What happens at equilibrium? I need that in order to figure out the equilibrium at CO. So you guys remember all the stuff that we did, 0.5, 0.5, and 3, and 5.04. Okay? So K is equal to 5.04. Concentration of H2 was what? 0.5. 50. Concentration of CO2 was? 0.5. And we were in 3 liters, right? This was moles. That was moles. So if I take each of those and divide them by 3, then I'll have concentration. Okay, so do that. Let's do concentration. 0.167. And that now is concentration. Everybody okay? I'm going to change from green because it's bugging me. Okay, so we had H2 plus CO2 going to CO and what? My brain just left. H2O. Okay. And these are all gases. So I'm going to set up an ice chart because what we have is initial. Okay, so initially we have 0.167. I didn't give myself very much room there, sorry. And over here we have 0 and 0, right? So we know it's going to shift towards the product. So minus x, plus x, plus x. So over here we're going to have 0.167 minus x, 0.167 minus x, x, and x. Right? So our Kc, if I set it up right, will be products, x squared, over everybody okay with that?
Yes.
Okay, so plugging in our Kc, which was 5.04, equals x squared divided by 0.167 minus x squared. Now, at this point, I want to take the square root of both sides, right? So I don't have any funky thing left. So somebody take the square root of 5.04 and give me a number. 2.24 equals x divided by 0.167 minus x. I'm going to stand up the page. So somebody times these two together. Okay, we'll go with this. All right, so then we're going to add the 2.24 to both sides, so we get 0.374 equals 3.24x. Everybody okay with that? Divide both sides by 3.24, and x is equal to what? Oh, sorry, not 3.24. Yes, 3.24. So if I add 2.24 to both sides, x, then I'm going to get 3 point because it's already 1. Okay, everybody okay? Okay, 0.115. Okay, and that is, don't circle, I'm going to go over here, CO concentration is equal to 0.115 molar. And they did ask for molar, right? Why is it 3.24 moles? When you add 2.24 to 1, because there's a 1 in front of that, right? There, I didn't circle it that way. I uncircled it.
Now you get it right.
Now I get it right. Okay, now if they'd asked for CO2 or H2, then I would have had to plug it back in here. Now, here's a quick check. Make sure that when I subtract 0.167 and the 0.115, I still have a number and it's not negative. If it's negative, I screwed up because I can't take more over than what I have, right? And I can look really quickly, yeah, I'm going to end up with 0.05 something, right? Okay, so we're good. Okay, so I've worked a few more with you. See what you can do on your own. Let's keep going. You got your 4 questions on the quiz. I want you to get them on the clicker, and I want you to get them stapled together and put it in the back. And I will put this up on